This is how you set up your Supabase credentials in n8n in under 5 minutes for you to build advanced AI agents using something called RAG, or Retrieval Augmented Generation. Let's get into it. Before we quickly set up the Google credentials here, I'm going to quickly talk about why do we actually need RAG in the first place. All these LLMs or large language models, be it for example GPT-5 or Anthropic Claude, they're pretty smart. Yet we would want them to have access to, for example, our PDFs in a company, for example, financial documents, legal documents, and so on and so forth. For that, we need to set up a RAG pipeline. For that, we need a vector storage, and this particular vector storage is then hosted on Supabase. That's exactly why we need to set it up. So I would assume that, for example, the Google Drive setup you already have done in n8n. We would use the download file particular functionality here. Again, the Google access is basically already given. We have the file, we have download, and then from the list, once again, you would set up anything that you would want to connect and then vectorize, put it into the database. So for this particular example, I'm going to use the Microsoft report that I downloaded before. The way this looks like, once again, it's basically a very fresh PDF from Microsoft around its 10K filing that just came out very recently. And once again, we would want to give the LLM access to interact with this particular document. It's around 60 some pages. We would vectorize that, put it into Supabase for the agents to then interact with it, and the user can answer and ask questions. Well, in order to do that, once again, we had to set up the download file functionality on n8n. We can also delete that here because we can initiate it, for example, with a chat functionality and or a webhook, for example, to a UI we would build in Versal v0. I would have a separate video on that if you're curious. But now let's quickly set up the Supabase component here. You go to Supabase, Supabase Vector Store, and we have different optionalities here. We can do it on schedule, on a webhook. What we actually want to do is we want to use it as documents to a vector store because we won't want to use this PDF sitting in Google Drive, and we want to put it into the vector storage. Now, I already have a Supabase account set up, but let me quickly start one up very fresh from the shelf here. We would go to create a new credential, and basically what is asked, let me quickly make myself a little bit smaller here. We need to do two things. We need to indicate the host, and we need to indicate the secret, the role, the service role secret. These are basically the two components we would need to set up in Supabase. For that, you would go to supabase.com. It would look something like this. After you're logged in, usually you have two free projects that you can actually set up. You go to a new project. I would call it test 2 because I did a few tests before. The password you actually also need to mention here as well. You can choose any arbitrary password that you would want to use. You can use the region, usually recommended is the Americas region, and you can go to create a new project. Once you have actually created a new project, it would spin up within Supabase. This might take between 5 to 10 seconds, depending on how busy Supabase is. What you actually have to check and quickly validate is the project status on the top right. This is green. Once again, you remember on n8n, we have to use two particular components, and these you will find under the settings element here on project settings. The first one is the host. We would go to Data API, and you would use this particular project URL that you can copy here from that particular project. We would just paste that here in the host. The second component, which is a little bit the more complicated / more custom component, is the API keys. Under service role secret, you would click on reveal, and then you would paste it also to n8n. I quickly do that, simply because I will redelete this project, so there is no data sensitivity here either. Let me quickly save that one, and it's then checking if the connection is successful. So once that is set up, it should always be green. So that's already inserted. Once we have, again, the Supabase account, we have insert documents. We can choose from the list a particular table. Now, we haven't yet created a table. Let's do that in the second step here. We go to docs as the link. You can scroll down. There is a quick start for setting up the vector store. You can click on here, and there's a few optionalities. What we want to do now is set up the table within Supabase for us to fill it in with the embedding vectors. There's two different ways you can do that. I usually prefer to go it over dashboard, as you can see here. Click on the SQL editor, then LangChain, and then run. We go back to Supabase. We exactly do that. So on the top left, you can see the SQL editor. You can go here. Under Quick Start, we will see the LangChain template. If you're running on a Mac, you can simply click Command Enter, or you can also alternatively click the green button. Let's quickly do that. It's basically setting up the table. If you can go here to Table Editor, we will see that here. Of course, it is yet still empty because we have to fill in the vectors in the first place. Also, once we actually have done it, quickly save it on n8n and then reopen it in Supabase components here. And we have the documents. Make sure you actually choose the documents one and not the RPC match document. So this is a particular correct table. We do also have some configurations on the embedding size, but don't worry too much about it. The last second thing, because we are a little bit over 5 minutes already, let me put that into the add-on. So that's basically how you would set it up. You would, again, go on save, and then you would basically just execute the step. Now, what it actually does is nothing yet, because we haven't configured the embedding model. What we actually have to do, maybe just very briefly, there is two particular components we would need. First, we need the default data loader, which is the chunking component, and that's pretty much just set up. Very small side note here, the document we're using is usually, if it's a PDF, a binary doc. So let's change the type from JSON to binary. Anything else you can leave as is. This is actually a fairly complicated piece of code. If you were to build it yourself on n8n, it's completely out of the box as well. Now, the second, a little bit more tricky component, especially if you build that outside of n8n, is which embedding models should we actually use in the first place. There's many different embedding models. Basically what it does, it's after the text is chunked, meaning split up into different textual components, we would use an embedding model to put it into a hyperdimensional or multidimensional vector space. This is exactly maybe the functionality we would need to do kind of to fill in the data table that we set up on Supabase. So you can think about it a bit like this. There's many different embedding models. We mostly use Cohere models for our Anthropic AWS-based services. That's for the business we are running. But in this particular tutorial, let me go with the OpenAI embedding models. Yet again, credentials need to be set up. I will also, just to quickly show that as well in this particular video, create a new credential on OpenAI's. And basically what we need to do, this is not the ChatGPT UI, you would need to go to the actual platform.openai.com, and then on the left side you see something called API keys. This is the list of API keys. You can create a new key. Let me call it, for example, test n8n, default project. That's completely okay. The only thing you need to do again is copy the key, go back to n8n, set it up. And then what we just did is basically we're connecting n8n to our OpenAI library. Basically, we connect the models we actually have in our library in OpenAI to n8n. Now, what you actually have now is the menu from different potential embedding models we can choose from. It's the text embedding large or small. The other one is a bit an older one, the legacy one. Let me quickly also show that actually, since we are anyway running a little bit over time, there is something called compare models. You can actually go to OpenAI and you can, for example, say embed large, and you can compare it to embed small. And there you see the differences. Let me review the other one. Again, they're mostly just a little bit better in terms of performance, meaning the embedding precision is a little bit better. If you were to build an advanced production system, you'll probably go with the embedding large. It's also a little bit slower, usually with larger and better models. And the pricing, again, funny enough, they don't mention it here. I will quickly showcase the difference in pricing in a second. We would usually then go for the small one. But let me quickly also talk about the pricing in itself. If we go back to models, we can look for the embedding model, the small one, if we're quickly checking. So for example, the small one runs at $0.2 per 1 million tokens to embed. And if we go back to embedding model large, I think it's like 6 times more expensive. Roughly, it's 0.13. So the cost of these embedding models, of course, matters. So the more documents we embed into the vector storage, the more pricey it actually becomes. So you actually have to be a little bit mindful which embedding model, similarly to which LLM you're usually running for your agents. But let's go back to n8n. Let's choose the small model because that's completely sufficient for this particular task. As we now have it set up completely, we can open this, execute step. And what it actually does now is, again, takes the embedding model, takes the data loader, and is executing the node just on n8n. This might actually take a few seconds. We now saw it's successfully executed. The embeddings actually are working. And you can see here, just very small, 278 and vectorize in our table that we have here. Let's quickly reload that. And yes, it's actually already working. You see all these 278 records actually. So all these embeddings are actually now here. In terms of the storage itself, it's where these particular embeddings are now being created. So it's a little bit, once we actually are using large language models to interact with this embedding storage, or with this embedding space, more to say, this is actually where it would retrieve the data. And then from the user's perspective, we could, for example, ask a question, and it would answer it. Again, getting to the PDF's information. So that's it. Actually 10 minutes and not 5. Now that just look at the time, but there's also a little bit of an add-on on the embedding models. So That's more or less it. If you want to see how you actually use this particular Supabase vector storage in a production-ready system, I have another tutorial just uploaded a few days ago where I really deep dive into how you would be building an agentic system that uses the embedding storage for retrieval augmented generation. Now, if I added value for you, feel free to also give a like, drop a comment if you have a question, and send you to the next tutorial. Take care. Bye-bye.